And so let's go look at Booleans first. And I did, okay. So let's talk about Booleans. So there's an entire field of mathematics, and I say mathematics because it is math. Talks about this concept of a Boolean value. And it's actually a person's name. I don't remember his rest of his name. I just know his last name was Boolean, and he kind of come up with this math. And we're going to use Booleans in conditional statements, and if conditional statements like if statements, they decide on things that we're going to do. But Booleans is a big part of it, and a Boolean has two values, true and false. Remember, when computers only understood ones and zeros, it's kind of a variation on that, but it's more of a true false, a yes no answer. So we can ask questions and get a true false back. And there's different ways to build Boolean expressions. We have Boolean operators. They're called comparison operators, and they're really good at comparing numbers. Greater than, less than. So we could do something like 5 less than 10. And if we drop that inside of idle, sorry, just trying to get rid of that. If we drop 5 less than 10 in idle, we get true. And it should be true, right? Because 5 is less than 10. So that says true. We could do other things as well. By the way, in addition to greater than, less than, we also have greater than equals. And I'll try to draw it so it doesn't look like a 7. We have less than equals. We also have a comparison operator called double equals. And notice that I put 2 equal signs. That's actually called the equality operator. This is equality. So checking to see if 2 numbers are identical. It is not a single equal. Single equal is an assignment. Double equal is equality. And so let's do some more. We did 5 less than 10, about 5 greater than 10. So obviously false, because that's not a true statement, right? 5 is not greater than 10. What about 6 equal to 7? Well, that's not true. So it's false. 6 equal to 6. That is true. Okay, so one of the key things here is that you can put numbers on each side of these Boolean operations. But you can also put any kind of expression in there you want, as long as it's a number. So we can put variables in here. X equals 10. X less than 20. 10 less than 20. Well, that's a true statement. X greater than 20. That's going to be a false statement because 10 greater than 20 is false. So here in these 2 lines here, we took the value 10, which was inside of X, and we placed it in both these situations. So 10 less than 20 is false, or true, and 10 greater than 20 is false. And so it just kind of replaced it. So we can put any kind of expression. This is an interesting one. So, math. This goes back to precedence. We know we do multiplications before additions. We also do additions and multiplications before we do Boolean operations. So the comparison operators are actually less precedence than math. So we do the math first. If I were to put parentheses around it, this is what it would look like. It would look like that. It would do those operations first. I'm going to do it without the parentheses, but that's what it's going to do. It's going to do the math first. Think about what this is going to give you for an answer. What's the current value of X? Current value of X is 10. 10 plus 10 is 20. Current value of X is 10. 2 times 10 is 20. 20 less than 20. That's actually not going to be true, right? 20 is not less than 20. It's not. So if we really wanted to check if they're equal, we could do an equality operator. And that is true because they are 20. And so we can do these comparisons of any kind of expression that has some sort of number in it. And we can do any combinations as well, right? We can build more advanced expressions. And we do that with combinators. So we can combine things together, and there are two of them. The first one is and. A combinator and, it means we can have two things have to be true, not just one thing for this to work. So we can say B1, let me actually write it over here. B1 and B2. This is only going to be true. Only true if B1 is true and B2 is true. So if this is true and this is true, then the whole thing ends up being true. Otherwise, it's going to be false. I don't know if any of you really know Venn diagrams and set theory, but I like doing this picture. If I have two sets, an and is actually an intersection. Only the things that actually are true are in both sides. So if something is true on one side and false on the other, it doesn't work. So it's intersection. So it's where both sides are true, do we actually include it and say the whole thing is true? And if we look at idle, so now we can write more complicated. So x greater than 0 and x less than 20. Well, we know x is 10. So 10 greater than 0, true. 10 less than 20, also true. True and true is true. All right, that's good. What if we change x to be some really large number? How about 100,000? Now, x greater than 0, well, that's true. 100,000 is greater than 0. X less than 20, no, that's false. 100,000 is much greater than 20, not less than 20. So the second statement is false. Because the second statement is false, the whole thing is false. So it's only true if both sides are true. And so we can combine any kind of Boolean operation we want using ands, but there's another one. There's actually a second one called or. And we can say B1 or B2. And or works a little differently. Or only one side has to be true. And so if we were to draw a picture of or, and it doesn't even have to be that picture. They don't have to have anything in common. But if it's in either set, the whole thing is true, as long as it's in either set. And we call this a union. As long as one side is true, so only true if one side is true. It doesn't matter which side either. So let's actually change this and statement a little bit. Let's do this one. Oh, I want to do this. This is interesting. I talked about this. I didn't show you what happens if you do an equals. Notice that equals is not a double equals. Does not allow assignment inside of a Boolean operation. So in order to fix this, I actually have to make this a double equal. Is this going to be true? X is currently 100,000. Let me run it. So X is 100,000. So equal to 0? No. Is it equal to 100? Also no. So both of those are actually going to be false. Now, if I wanted to make this statement true, I can set X equal to 0. And now the left side is true. This part's true. This part's this part's false. Only one side has to be true for this whole thing to be true. So that's the way the OR operator works. So we have these two operators, and No, I keep using that word and. So first we do parentheses, then we do exponent, and then we do multiplication, division, and modulo. Then we do these. Then we do those. Then we do ands, and then we do ors. Because you can combine ands and ors together to create even bigger things. So for example, if I'm hungry and I have $5, I can drive to McDonald's. Well, what if I don't have my keys? If I'm hungry, I have $5, but I can't find my keys, I'm not going to McDonald's. So we can combine things, but regardless, and then finally the last one down here is the assignment operator. We do assignments last. So the order of precedence now is actually expanded with those equality operators, and or also have precedence. We do all the ands before we do the ors. Although I think, yeah, I can't try to remember completely. I know that's Java is true. I think it's true in Python as well. I'm not going to do any examples of that because it's not that important for what we're doing here. We have one more operator I want to look at though. It's called the not operator. Any of you play when you're kids and say not it? It's exactly what we're saying here. So not actually takes a single Boolean and it reverses it, basically inverts it. So when I say not something, if it's true, not true is false. If I say not false, well, now it's true. So it actually inverts it, it flips it. And so we can actually take, so right now x equals 0. But if I say not, remember, this just turned true a second ago. But now the whole thing is false. Initially, it was true. So now it did the true statement and did a not on it and turned the whole thing false. Or we could do one side or the other. Not x equals 0 or x equals 100. Also false because neither of these is actually true. Now, this is such a common pattern. There's actually another way of doing this. And it's actually it's actually called the inequality operator. It's an exclamation point. Inequality, which is just another operator over here, which is basically saying if things are not equal. So instead of writing the not in there, I could say x not equals 0 or x equals 100. Those two lines are identical. The second line is simpler and a little clearer about what happened. And so we could, instead of not using the not operator, use the not equal operator. And if memory serves, I believe the not operator happens near the top somewhere. I'm trying to remember. I don't remember exactly where it goes. But it happens before these. So it's somewhere around here. We only use it with Boolean values. So the fact that it has to happen before precedence 5 is fine, because we only use it with Booleans. And the only Booleans operations we have are 5, 6, and 7. So it happens before 5. I don't remember exactly where, and I looked it up and then I completely forgot where. So it happens somewhere. It doesn't happen before parentheses, but it happens somewhere else. So we have all of those operators. And if we want to just do a simplistic one, just to look at it, x not equals 0. Remember, x is currently 0, so x not equals 0 gives us false. Because actually it's true. And so it's the opposite of it. So that's what's happening when we're doing either of these things. This one actually flipped this whole line.